Okay, so for this lesson, we're going to focus on how to determine if two triangles are similar. So just to review, we know that similar means the same shape but a different size. Or that's kind of the concept of what similar means. There's a more specific definition, but for now we'll think of it as same shape, different size. So there's two main ways that we're going to check if two triangles are similar. So the first way is checking if the angles are congruent. And so if I look at these two triangles, let's look at this first example. I see that this side, this angle is 15 and this is 90. And this one is 90 and 70. So before I can check if these two triangles are congruent, I need to find out what their missing angles are. So I will start on this top triangle. I can do 180 minus 90 minus 75. And that leaves me with 15. And then if I do the same thing down here on this bottom triangle, I can do 180 minus 90 minus 15, and that leaves me with 75. And so I can see that these two triangles, because they have congruent angles, so when all the angles are congruent, the triangles are similar. And because of the way that triangles work, even if two of the angles are congruent, then we know the third angle is congruent. And so that means that there's the angle similarity. So this is just meaning that two angles is actually enough. So what all that means is that two angles is enough. So once you see that two angles are congruent, then you know the triangles are similar. The other way, so this is one type of similarity, angle similarity. The other type of similarity is if all the sides, I guess I should say all the pairs of corresponding sides have the same ratio. And so the way we check that is we need to line up the sides and make sure that we're finding the ratios of the corresponding sides. So when they give me all of the sides like this, I can just match them up by size and check. So 12 to 8 will be one of my ratios, and I can divide that out and see that I get 1.5. So let's check my other pairs of sides. So those were my two longest sides. Now I can check my two shortest sides. And I always want to make sure that I'm dividing the bigger triangle by the smaller triangle. Or you could do it the other way around, as long as you do it the same every time. So 6 divided by 4 gets me the ratio of 1.5. And then last but not least, I'll do 9 divided by 6, and that gets me the ratio of 1.5. So if all the pairs of corresponding sides have the same ratio, then the triangles are similar. And so this one's called side similarity. So the key thing to check is that you make sure you're setting up your ratios correctly if you put the bigger triangle on top, you have to put the bigger triangle on top for all the ratios. You could also put the smaller triangle on top and do it for all the ratios, and then make sure you line up corresponding sides. That's really important. So these are the two ways to check if two triangles are similar, and we're going to practice that by looking at different pairs of triangles and checking for these two. So let's start with example 1. So take a minute, copy down the triangles, and see if you can figure out if these two triangles are similar or not. I have to do the math. So I can see they've only given me two angles, and they both have 62, but I don't know if the other angles are going to match. So let's find for this missing angle. So I'll do 180 minus 92 minus 62 and see what that gets me. 26. So I can see from here that these two 26 goes here. So I don't even need to find this one. I already know it's going to be 92. So these triangles are similar. By angle, because they have two pairs of congruent angles. I don't know anything about the sides, and I couldn't solve for the sides because they didn't tell me anything. But I know that they're going to fit into the same ratio because they have the same angles. So let's try another example. Let's look at, okay, so take a minute and look at this one. So this one, they're giving me the sides, so I have to check the ratio. So we'll check ratio of the sides. So let's see. So the smallest side over here is 6. I'm sorry, the smallest side over here is 2, and the smallest side over here is 5. So I'll just do 5 divided by 2 is 2.5. Let's see, the next one is 3 and 6. 6 divided by 3 is 2. So I don't even have to check the last side. I can already see these are not similar because the corresponding sides do not have equivalent ratios. So that's the basic process. We'll do a couple more examples, and hopefully it will start to seem pretty simple. So why don't you guys try this example? So try to line up the sides correctly. So figure out which side lines up with which side and check out your ratios. So pause the video for a second and see if you can check if these two triangles are similar. Okay, so hopefully you tried it. Let's see. I'll start with the longest side. So the longest side here is 77 and 22. 77 divided by 22 is 3.5. So let's check if my other ratios work out. My smallest side is 42 to 12. So you have to pay attention to which, that one also gives me, I think, 3.5. You have to pay attention to which sides line up. So these are both, so I like to start with the biggest and the smallest. This one also gives me 3.5. So now let's check the last one. 49 divided by 14. I think that's also 3.5. Let's see what it tells me. 49 divided by 14 is also 3.5. Great. So these triangles are similar. Are similar. All three pairs of corresponding sides have the same ratio. Okay, we'll try a couple more and hopefully it will seem easy. So why don't you guys again pause the video for this one? I think this is example, what is it? 4. Okay, so try to set up your ratios and check and see if this one works out to be equivalent, to have equivalent ratios or not. So this one is nice because they already kind of lined it up for me. So I'll just start 20 divided by 10 is 2. This one's easy to just check. I can quickly see, well, 25 divided by 15 is 1.666. So that's not, I can see just by checking two ratios, these are not similar. The ratios are not the same. Okay, let's check two more with angles. And this one is a bit trickier. This one we have to use a little bit of our angle knowledge. So take a minute and copy this one down and see what you can find out about the missing angles in this pair of triangles. So hopefully you quickly notice that there would be, so first of all, before I can say anything, I have to find the missing angles. So I'm going to start by noticing that that's 42 because I have vertical angles. So let's always make sure we notice vertical angles. And so now I just need to solve for the missing angles to see if they match up. So I can see they have one pair of angles matching. Let's check the other one. So I'll do 180 minus 53 minus 42. And let's see if that gets me 85. It does. So I don't even need to find the other angle. I can just say they have two congruent angles. So they are similar. I think that should be plenty of angle examples because the next one is just the same concept. So there's just one last thing that I want you to know about, which we're not going to focus on as much, but there's one other way to check similarity, and that's side angle side similarity. And so that's when one angle is congruent and the two sides next to that angle, next to the angle, have the same ratio. So it's kind of a mix of the two ways. And we're just going to do two examples just so you can see how that would work. So this one, they're telling us that these two angles match, which means I just need to check the ratios of these two sides next to them. So 117 is the bigger side, and it lines up to 13. It corresponds to 13. So I'll do that. I'll check that angle, which is that ratio, which is 9. And then I'll just check the other ratio. And I think I know 108 divided by 12. I think that one's also 9. Great. So if the two sides have the same ratio and the included angle is congruent, then they're similar. So two sides, or I guess two pairs of sides, have same ratio, and the included angle is congruent. So if you want to check that one out, why don't we just try this one example? This time, again, you would notice that there's these vertical angles. And so when there's vertical angles, I just need to check the corresponding side. So again, make sure you're lining them up, right? So if this side's smaller, it lines up, it corresponds to the smaller side here. So 140 divided by 30 is 4.6667. And then let's try this other ratio, 182 divided by 39. And let's see if that's right. Great. So those match. So there's really 3 ways to check if your triangles are similar. We'll practice it more in class, but make sure you have these 3 ways down in your notes. You can follow along in the lesson tomorrow.